Hey everybody, this is Mr. Longo, and in this video we are going to cover complex zeros. If you don't remember what complex numbers are, it means, in a way, imaginary numbers, or the combination of a real and imaginary number. So, one thing you need to remember about imaginary numbers is that they always come in pairs. You probably remember when you take a square root of a negative, we always put plus or minus. So, we would have a negative 2i that goes along automatically with a positive 2i, and a 4 plus 3i, which is known as a conjugate, where you just switch. It's you have your plus and minus for your i's. But we have to remember that imaginary numbers always come in pairs, because we're going to be doing a variety of problems that require you to know that information. For example, the first one. It says write a fourth degree polynomial with zeros of I and 1 plus 2i. So that means you have to remember that that's actually going to have a negative I as well, and it's going to have a 1 minus 2i as well. So there are multiple ways to do this problem. I can tell you one of the ways is to simply write where these came from. So that would be an I would come from x minus I, and a negative I would come from x plus I. And what you would do is FOIL those. And to do that, it's just x times x is x squared, x times a positive I is positive ix, negative I times x is a negative ix, and then a negative I times a positive I is a negative I squared. So things you have to remember is that, well, obviously those guys cancel, but I squared is a negative 1. So this is going to give you x squared plus 1. And that's how you get one of your terms. Now there's another way to do it. The other way is, instead of doing it this way, you would write it as x equals plus or minus I and work backwards. I will show you how to do that with the I, or the 1 minus 2i. So what we would do is write this as x equals 1 plus or minus 2i. And remember, that came from solving something. It was originally equal to 0. So you just reverse your solving process and go back to where it came from. So right before it was 1 plus or minus 2i, it was x minus 1 is equal to plus or minus 2i, because that's the last step, was to add 1 to the other side. Now, where did your i's come from? I's come from square rooting a negative. So to get rid of the i's, we would just square both sides. Okay, do not forget that when you wrap something in parentheses and square it, what you're really doing is multiplying that set of parentheses to itself. So we're going to be multiplying, FOILing, distributing, whatever you want to call it. And that's going to give you x squared minus 2x plus 1 equals. Now remember, 2i squared is going to give you a negative 4. Because remember, 2 squared is 4, but I squared is a negative 1. Add that 4 back over to the other side, and you get x squared minus 2x plus 1, or plus 5 equals 0 after you add the 4 back over. Okay, and that would be your other term. So your fourth degree polynomial written in factored form would be f of x is equal to x squared plus 1 times x squared minus 2x plus 5. Now again, you could have taken this and you could have said that came from x minus 1 minus 2i, and you could have said x minus 1 plus 2i, and you could have FOILed those together, but that would be a lot of multiplying with i's and x's to do, but it absolutely works if you want it to. Okay, so one of the things you need to be able to do is multiply with i's. I want you to know your calculator can multiply i's. If you've never done it before, it's the second and then press the decimal button. So you can actually do 2i parentheses 3 plus 5i and click enter. Your calculator will give you that answer in a complex number. So if you've never tried that before, do it, because that would be very helpful for what's coming up next. 2i is a 0, find the other zeros. This is synthetic division. You have done synthetic division with real numbers before. Now we're going to do it with imaginary numbers. The trick is this is going to take 2 steps to do. Okay? So, imaginary numbers just makes the multiplying part a little bit more complicated, but you'll see how it's going to work out. So, remember with synthetic division, you are going to have the leading coefficients of all the terms without skipping. So we have 1x to the 4th. We do not have an x cubed, but we need a placeholder for it. We have 13x squared. We have no x's, and then we have a constant of 36. Now, what you are dividing by is one of your zeros. So we were given that 2i is a 0. But there is a catch. Remember, they come in pairs, so negative 2i is also a 0. Okay? Now, here's where the fun part happens. If you do not remember regular synthetic division, you should refresh your memory with that. But the first thing you always do is bring down the first term. It's a 1. But then this is where you multiply 2i times 1, which is 2i, and you put it right underneath the next term, and then you add those together. Okay, so 0 plus 2i is 2i. And then you're going to do 2i times 2i, which is 4i squared. But remember, I squared is a negative 1, so this is actually going to be a negative 4. And you have to be able to do that. Again, if you type 2i times 2i in your graphing calculator, it will give you a negative 4. Okay, so 13 minus 4 is going to give you 9. And then that's what you're going to keep on doing. 2i times 9 is 18i. And of course, add 0 and 18i, you still have 18i. 2i times 18i is going to give you a 36i squared, but we know that better as a negative 36, which means those guys are going to cancel and you have no remainder. However, you still have i's, which is why you have to do synthetic division again right afterwards with the other part of the I. So we had a positive 2i, now we're going to do it with the negative 2i. But you're going to do the same thing, bring down the 1. Negative 2i times 1 is a negative 2i, so look, now our i's are going to go away. And then, of course, that negative 2i times 0 is 0, so that's going to give us a 9. Negative 2i times 9 is going to give us a negative 18i, which is going to go away. We now have no remainder. So back in the day with synthetic division, you learned that when you divide, you're dropping this a term. Since we divided twice, this x to the 4th becomes x to the 3rd. Now it becomes x squared. So this is 1 x squared plus 0x plus 9, which means we have x squared plus 9. Okay? That is what we get when we divide those out. Set that equal to 0 and solve. X squared is equal to a negative 9. Square root both sides, do not forget, that means you have a plus or minus. So x is equal to plus or minus 3i. So that was a lot of work to get that, but that's just one of the things you have to be able to do when you are in the pre-calc level doing synthetic division and working with polynomials. So if you thought that one was crazy, check this guy out. You have to do synthetic division with 2 plus 3i and 2 minus 3i. However, the thought process is the exact same. So we're going to just set it up really quick. We're going to have a 3, negative 1, negative 9, 159, and a negative 52. And we are going to divide by 2 plus 3i first, using synthetic division. The steps are the exact same. It's just going to be a little bit trickier. But since you know the thought process, I would like you to pause the video and give it a try on your own and see how you can do. Give it a shot. Okay, bring down the 3, and you're going to multiply 2 plus 3i, and you are going to end up with 6 plus 9i, and add those together. You use your real numbers together and your imaginary numbers. So -1 plus 6 is going to give you 5 plus 9i. There were no i's to combine. You're combining like terms here. And then you're going to multiply, meaning you have to multiply those pieces together. And that guy is going to give you something even crazier. It is going to give you a -17 plus 33i. Again, you can FOIL those two together, or you can type in your calculator 2 plus 3i times 5 plus 9i. Your graphing calculator will give you the correct answer. Okay? And then, of course, -9 and a -17. You can do that in your calculator as well. Is going to give you a -26 plus 33i, and you just keep on going. Yes, it's going to be big and ugly, but you just have to deal with it. Again, use your calculator to your advantage. I am not going to tell you you have to do this by hand on a quiz or a test. So make sure you know how to use it. And if everything works out correctly by the time you get to the last step, you're going to get a positive 52. So a -52 and a positive 52 are going to cancel each other out, and you have no remainder. And then you do it again with 2 minus 3i. So yes, you need a calculator. You need to know how to use it, and this will make the job actually pretty simple. So just to save time, if you are multiplying all of these 2 minus 3i times 3, you're just going to get your 6, and your minus your 9i. We're going to combine these together, and 5 plus 6 is going to give you your 1. But look, your i's, or 11, I'm sorry, your i's are going to cancel. And then you're going to multiply that together. 2 times 11 is going to give you a 22, minus, and then you're going to have your 33i. And look, -26, 22, that's going to give you a -4, but your positive 33 and your negative 33i's are going to cancel. And you're just going to keep on doing that until you end up with a -8 plus 12i. Those are going to both cancel, and you have no remainder. So you end up with we started at the fourth, became a cube, became squared. This is 3x squared plus 11x minus 4 equals 0. So of course you're going to have to finish by factoring. This is going to factor to a 3x minus 1 times x plus 4. Set each of those terms equal to 0, and you're going to get x is equal to a positive 1/3 and a -4. And of course, you already have your 2 plus 3i from the beginning, which is also part of this. So yeah, that's a lot of work to get done. I understand. But you know what? Sometimes you just got to do what you got to do. Anyway, complex zeros. That was a big one, y'all. This is Longo, and I'm out. See you, bye.